about countercurrent exchange, which occurs in the vasa recta. The vasa recta is located in the medulla of the kidneys, and it's important for maintaining osmolarity. You can see right here that we have the vasa recta, and then it's adjacent to the loop of Henle. We're going to be focusing on the descending limb, where blood enters, and then the ascending limb, where blood is released. Now let's take a look of the vasa recta. So we have the efferent atrial, and it starts off with 300 milliosmoles, and then it ends with 1,200 milliosmoles. This efferent atrial is actually side by side with the descending limb. So it picks up the sodium chloride from the outside extracellular fluid and gets reabsorbed into the bloodstream. Then the water from the bloodstream is released into the extracellular fluid, and this causes a dilution. Well, this exchange is supposed to be highly concentrated, but there's just a dilution that occurred. So we have to go to the vein, which is on the other side. This vein will push out sodium chloride into this extracellular fluid, and then water is pushed back into this vein and reabsorbed into the bloodstream. And you can see right here that we end up with 325 milliosmoles. And if you see right here, we started with 300. So that means that the volume ends up being greater at the end than it did at the beginning. Now let's take a look at ADH. ADH is a hormone that helps the secretion of urine. So I'll be talking about what happens when ADH isn't present, and then what happens when ADH is present. So right here we have the loop of Henle, and then if you keep on following it, we have what is called the collecting duct. In this collecting duct, there are these side things that are called transporters. These transporters are what release water that is inside this collecting duct. But without ADH, we are unable, or it's unable to release that water. So water becomes trapped in this duct, and it'll cause dehydration and then large volume of diluted urine. So now let's talk about what happens if ADH is present. So we have the loop of Henle again, and then the collecting duct. So they have these transporters, and in these transporters there is called aquaporins. So ADH binds to these aquaporins that are inside the transporters, and when they bind, it allows water to pass through and get reabsorbed. So you can see right here, water got passed through and it's sent to the extracellular fluid, and that causes an increase in extracellular fluid of osmolarity. And the result will lead to a small volume of concentrated urine. So